Hello students, welcome to Soft's classes. Today we'll be talking about particular integrals. So particular integrals are a part of the general solution of the linear differential equation. Basically, the general solution of a linear differential equation is of the form where y is equal to a complementary function plus a particular integral. We have already talked about the linear differential equation and then we have talked about the complementary function. Today we'll talk about the particular integrals. So now if we consider a linear differential equation of the format dn plus d, let me write it down once again, plus k1 into d to the power n minus 1 plus k2 into d to the power n minus 2 up till kn into y, and that is equal to capital X if we consider a linear differential equation of this format then the particular integral, which is denoted by p of I, will be equal to 1 upon dn plus k1 into d to the power n minus 1 up till kn into capital X. Now this entire thing can be written down as f of d, function of d. So therefore this becomes 1 by f of d into x. So particular integral is equal to 1 by f of d into x. Now there are some particular cases that we need to consider. Suppose case 1. So case 1 will be when capital X is equal to e to the power ax. In that case particular integral is equal to 1 by f of d into e to the power ax, and this will be equal to 1 by f of a into e to the power ax if f of a is not equal to 0. So this is case 1. Let me go to case 2. So case 2 will be, now this case is not entirely finished. Suppose if f of a is equal to 0. Now if f of a is equal to 0, if f of a is equal to 0, then particular integral will be equal to 1 by f dash a into x into e to the power ax if f dash a is not equal to 0. So this is if f of a is equal to 0 and f dash a is not equal to 0. Now if f dash a is also equal to 0, then particular integral will be of the format x square by f double dash a into e to the power ax, provided f double dash a is not equal to 0. So this is the second case in entirety. Second case. Now we'll go on to the next case, which will be case. So case 2 will be when capital X is equal to sine of ax. So if sine x is equal to sine of ax, then particular integral will be of the format 1 by f of d square into sine of ax. So this will be equal to 1 by f of minus of a square into sine of ax if f of minus a square is not equal to 0. Let me go to the third case. So third case is when capital X is equal to cos of ax. So in that case particular integral will be of the format 1 by f d square into cos of ax, and this will be equal to 1 by f of minus of a square into cos of ax if f of minus of a square is not equal to 0. Let me go to the fourth case, which will be case 4. In this case, when x is equal to small x to the power m, then particular integral will be of the format 1 by f of d into x to the power m, and this will be equal to, now this 1 by f of d we can write down as f of d to the power minus 1 into x to the power m. Now this f of d to the power minus 1 will be expanded, or that implies that expansion of f of d to the power minus 1, and this will be carried out up till the term d to the power m, because d to the power m as the m plus 1th term, or basically any other terms, that is d to the power m plus 1 and higher terms or the derivatives of xm are 0. So basically up to dm it is existing, d to the power m plus 1 and higher derivatives of x to the power m are all 0. So we expand only up till d to the power m. So this is the thing that one needs to be careful about. Now we'll go on to the fifth case, that is case 5. So case 5 will be that when x is equal to e to the power ax into some function v of x, in that case the particular integral will be of the format 1 by f of d into e to the power ax into v to the power x, and this will be equal to e to the power ax into 1 by f of d plus a into v to vx. So this is to be kept in mind. And the last case will be, which will be the case 6. This will be when x, let me write it down again, when capital X will be equal to x into some function vx, then particular integral will be of the format 1 by f of d into x into vx, and this will be equal to mod of x minus f dash d by f of d into 1 by f of d into v of x. So these are the various cases that one needs to keep in mind. So therefore, before we complete, let me tell you the complete steps that should be incorporated if we want to have the complete solution. So now I will be telling you about the steps to calculate the complete solution. Steps to calculate the complete solution. So the first thing that one needs to do is that we need to find the auxiliary equation from the linear differential equation. This is the first step. And the second thing that you need to do is that calculate the complementary function using the cases. using the cases. And the third thing that you need to do is that you need to calculate the particular integral using the cases as mentioned. And in the fourth step, what you will try to do, the complete solution will be of the format y will be equal to complementary function plus the particular integral. So these are the steps that you need to follow. So today we have learned about particular integral and the steps to calculate the complete solution. If you have any doubts regarding linear differential equation, about a complementary function, about a particular integral and the various cases, then you can mention that in the comment section below and we'll try to get back to you. Thank you very much.